I want to give some free advertising for Lowe's and Radio Shack. They're both really great stores for electrical supplies. This is a basic electronics video showing how to use a meter around the house to make various electrical tests, and also how to use test lights and a soldering gun. These are all very easy to use. All these tools shown in this video, with the exception of the meter, are available at Lowe's or Radio Shack. This is a Craftsman Multimeter that I bought at Sears on sale for a little over $10 about 6 years ago. They can still be had for $12 to $14 on sale. This multimeter is very easy to use. It's commonly called a voltmeter, but it does much more than that. I'll show you in this video how to make some very simple tests using this meter. The black test lead plugs into the center connector shown by the green arrow. Your red test lead plugs into the right-hand connector shown by the green arrow. The far left connector on this meter, your red test lead would plug into that if you were going to test for amps. We won't be doing that today. Upper left-hand corner is volts DC, like if you were checking something on your car. You could set it to 20 volts because what you're going to be dealing with on a car is going to be 12 volts. Just to the right of the off position, you will see AC volts. And today we'll be testing household current, which is 120 or 220, but we won't be testing 220 today. The lower right-hand corner in the blue is for testing batteries like 9-volt batteries or AA, D cells, etc. And that's what you'll be using to test your batteries. D batteries, AA, and AAA batteries are all 1.5 volts, just different amps. The black test lead plugs into the center connector on the meter, and the red test lead plugs into the right connector on the meter. Alligator clips can also be used with these test leads. They just push onto the end and make it a little bit easier to use the test leads. Here are the alligator clips. They didn't come with this cheap meter. You can purchase them and just about anything else you see in this video at Radio Shack. Here's a close-up view of an alligator clip. This photo shows the polarity indicator on the meter if you hook your leads to the wrong terminals on a battery. No harm done, you'll still get the voltage reading, but it just shows you that you have your leads hooked incorrectly. Now the leads are correctly hooked up to the battery and you don't see that polarity indicator. If two batteries are hooked up in parallel with wires as shown here, you still get 1.5 volts. If batteries are hooked up in series as shown here, as many flashlights have, then the voltage is double. You have 3 volts. Most people are not aware that rechargeable batteries have a lower voltage than standard batteries, even when fully charged. They also lose their charge over a period of time, whereas a standard battery will hold its charge almost indefinitely. I had trouble with my Kodak cameras using other brands of rechargeable batteries until I went to Kodak. That cured the problem. The cameras worked properly then, so that's something to keep in mind. Rechargeable batteries are great for cameras if you carry a spare set. And they're great for toys, but they're not good for remotes because they don't hold their voltage for a long period of time. Everyone is familiar with these little transformers that you plug into the wall. They're used on computers and computer accessories and camera chargers, battery chargers, phone chargers, etc. These little transformers convert 120 volts, which is dangerous, to a lower voltage, either AC or DC. The converted output voltage is very safe, so don't be afraid of these little transformers. They won't hurt you. I have all my little transformers like this associated with my computer. I have them hooked up on switches so that when the computer's off, these don't continue to drain voltage. Maybe I'm just a fanatic, but if everyone would disconnect these transformers when not in use, it would save a tremendous amount of energy. The output on this transformer is 12 volts DC. Set your meter to 20 volts DC Insert one probe on the inside center terminal of this little adapter. Your other lead goes on the outside that you can see here, the silver portion. Read the voltage. You should read 12 volts DC. If the output data on this transformer just shows volts, it's more than likely AC. If it was DC, it usually states that. Shown here are two fuses. The one on the left is an auto fuse, and the one on the right can be used in automotive and many other applications. These can easily be tested by using your meter's continuity setting. The soft metal link that burns in two when a short occurs is clearly shown in both of these fuses. Shown here are two terminals. They come in many different sizes and configurations, and they're also color-coded when they have an insulating sleeve like the one on the left. The right ring terminal shows a split in the barrel where you crimp it. It is very important to position that barrel in the proper place when you use a crimping tool. If this split in the barrel is not properly positioned in the tool can actually push this split apart. This is an insulated butt connector, and it's used to connect two wires together by crimping. Position the electrical connector with a split in the barrel away from the yellow arrow shown here so that the tool does not push the split in the barrel apart. This shows the terminal properly positioned in the crimping tool. If you would notice, the projection on the other side of the arrow would push that split in the terminal apart if you had it turned the other way. Here's another view of that. Heat shrink tubing comes in many different sizes and lengths and colors and can be cut to the desired length and slid over the wire before you make the soldered connection, and the heat shrink tubing needs to be slid back on the wire far enough away from the soldered connection so that the tubing does not shrink. This is the most professional way to cover a soldered connection. You can use a high quality electrical tape like Scotch, the only one that I would use. When you have several wires soldered together and each one covered with a piece of heat shrink tubing, you can cover all of these connections with a larger piece of heat shrink tubing rather than wrapping it with electrical tape. To test this 20 amp automotive fuse while still in the car, hook your test light to both sides of this fuse as shown by the arrow. You should have 12 volts on both sides if testing with a meter, or your light should light if testing with a light. If not, the fuse is blown. Be sure that your meter or test light is properly grounded to the metal part of the car. Here you see on this automotive blade type fuse the piece of soft metal that blows when a short happens. The green arrow shows the filament in an incandescent bulb as used in the home and in automotive uses. The yellow arrow shows the base of the bulb, and the neutral wire makes contact with this base. The red arrow shows where the hot wire, also referred to as line in, makes contact with the center contact of the bulb. These are Electricians Pliers. They have insulated handles, they also cut wire, and they have a big, wide, long jaw to enable you to twist wires easier than with a standard pair of pliers. These are not necessary but nice to have. The tool shown here cuts wire, crimps both insulated and uninsulated terminals, also cuts small threaded screws, and strips wire. This tool did all that the previous tool did, but it also has a small pair of jaws, plier jaws, on the tip of this tool. Here is a typical receptacle. If properly installed, it should look just like this, a small face. The red arrow shows the mounting holes that mount it to the box, and the green arrow shows the green screw that the ground wire attaches to. The blue arrow in the center is where the cover for the receptacle screw goes. If you wanted to change a receptacle, the first thing you would do, of course, would be to cut power. To do that, you could plug a radio in this, turn it up loud, then go to your breaker box and flip the breakers until the radio cuts off. And of course you can also check it with your meters and your testers. I always check and double check before I proceed. All electrical outlets, receptacles, switches are available from Lowe's. And they're very inexpensive and very easy to change, so don't be intimidated by this. Of course, receptacles come in many different colors, and you can also get them heavy duty for industrial uses. Be sure when you buy receptacles to buy them with the ground hole, the small bottom hole at the bottom of the face, which looks like a mouth. Make sure you buy it that way, because some are still available without ground. As you look at this, what appears to be a face, the right eye, or the right terminal, would be the line in, or the hot wire. The left terminal, which is larger, is your neutral wire. And of course the little opening that looks like a mouth, that's the ground terminal. The red arrow shows two brass screws on the right hand side. These are for your line in, your hot connection. These additional terminals would be used if you wanted to install another receptacle not far away. You could attach your wire to this and go on to your next receptacle. Also, you can use these terminals. You can split these two apart and use a switch to control one outlet of this two outlet receptacle. I'll show you that in a few minutes. The terminals on the left here, shown by the blue arrow on the left hand side, these are the neutral wire connections. The ground wire goes where the green arrow is. My home is an older home and isn't wired for grounds. The receptacles don't have grounds. You can run a ground wire, as I had to do for the receptacle for my computer. You can run a ground wire from the green screw to the closest water pipe and clamp it. That will give you a good secure ground. This may or may not be an easy thing for you to do, because in some cases you have to pull a wire, and pulling a wire through a wall without the proper tools is a really hard thing to do. It can be done with coat hangers if you're going a short distance, but it's not a very easy thing to do. To properly protect my computer and my surge protector, the surge protector had to be grounded in order to operate, so I had to run a ground wire. Light switches are so easy to change. Just make sure that the current's off. There's just two wires going to it. Both of them are hot. Hot wire comes in, then when it's switched on, it goes out the other side. So they're very easy to change. This light switch also has a provision for a ground wire, which wouldn't be used in an older home because no ground wire is provided. This light switch is a little different from the receptacle shown in this video. You can strip your wires with a wire stripper and insert them where the red arrows are. That's a real quick and easy way to do it. However, I don't recommend doing that because my son had a receptacle that was wired this way and it was giving trouble. When he removed these wires, and you can do so by inserting a paper clip in that little slot and then pulling the wire out, when he removed those wires and then made a loop in them, wrapped them around the screws that you see here with the blue arrow, wrapped them around that and tightened them that way, it's a much more secure, much better connection. He had no problems from there on. Strip the wire and loop it around the screw, and loop it around the screw in such a way that when you tighten the screw, it doesn't tend to push the wire out. You'll see what I'm talking about when you do it. The wire would be wrapped around the screw clockwise, and likewise the screw would be tightened clockwise. In the next photo you'll see a receptacle of a different brand, and it hooks up differently. It does not have that provision to strip and slide a wire in the hole as you see here, which is just as well. Like I say, I really don't like to use that. There are two brands of receptacles on the market that I've seen at Lowe's, and both slightly differ. Now this one here, the small green arrow, shows that when you loosen the screw at the red arrow, there's a small brass block that moves out of the way. You slide your wire down between these two blocks and tighten the screw. It's just that easy. Also shown by the blue arrow is a connector that you can cut in order to separate these two outlets in this one receptacle, and therefore you could put one outlet on a switch if you'd like to. And the black arrow shows the green grounding screw that I've shown before. You can see by the little red outlined boxes that one says white wire, one says hot wire. Your silver screw is always on the left-hand side and is always for the neutral wire. The brass screw is on the right-hand side and it is for the hot wire. In many different schematics or wiring diagrams, the hot wire is often referred to as line in. I want to repeat that again.